Hello, this is a demonstration of my physics IPT ballistic simulation. We are feature complete now. I can set a launch angle. There we go. I can set the force of gravity if I really want to for fun. I can set a wind velocity, importantly. This is important for air resistance. And I can set a cartridge with info. So we're gonna obviously pick the fastest flying cartridge, and we're going to launch it at about 4 degrees and fire. There we are. Hit at about 2 kilometers or 1.89 kilometers. So it'll save the trajectory from the last attempt. Let's put it at 3.9 degrees again, and let's try this. Now I also have bullet view. Yellow line is FNet. Red line is velocity. There's a white line that's sort of matching the trajectory that's drag. So force drag hits the bullet a lot. And so you can see I actually lose a lot of kinetic energy just because, first of all, I'm going upwards, but by the end, probably the kinetic energy should have lowered because it is working against my other force for the distance in which the bullet travels. So I ultimately get a lower number. That being said, let's up the gravity. So this is at 15 degrees, which is a lot for a gun. But it's falling very, very quickly, and it has hit the floor. Still an impressive 2.7 kilometers. So if I really want to analyze this, I can set the time scale down, and that'll slow everything down a little. So here I can view my velocity. This is angle from the horizontal. I can see my Mach speed, my altitude, my force drag in scientific notation, FNet also in scientific notation, the local air pressure, which is being calculated off of altitude, as well as the local speed of sound, which is being calculated off of altitude, and finally the current kinetic energy. So that's that. I think that's everything. It's going very, very slowly right now, as you can see. In fact, I can actually just stop it completely if I want to save my variables here. Or I can speed it all the way back up. And there we go. So how this works will be explained in the accompanying document. I couldn't get this working like a web deployed version, unfortunately, so you will have to trust me by the video. But here we are. So if I set velocity of wind to be negative, this should be shorter, but not by much. Seems like angle is the big determining factor at the start, mostly because the coefficient of drag is a lot lower at the Mach speed that I'm going. So wind actually doesn't have a huge effect on things. Although If this was 3D, that would be a very different situation. That would be a question of accuracy and not just displacement. So that's that. Thank you for watching.